All right, for the second part of 9.1, one of the things that we dealt with in the first video was the idea of having a plus c, and we said that could represent any constant simply because whenever you have a function like this and you were to take a derivative, the constant goes away when you get the derivative. And so if you were to try to go back the other way, you would have no idea of knowing what constant this could have been. It could have been any constant under the sun, and so that's why whenever we do the integral, or when we anti-differentiate and go from here to here, we represent this with a plus c, simply so that we have a family of functions and it can represent any function with any constant in that place. And so we were getting answers like this, and so part 2 of this video is now dedicated to coming up with a number for this if they give you enough information to do it. And so if you take a look at a few examples here with me. So here we are starting with the derivative of 6x minus 4, and we're going to go the other way and we're going to integrate 6x minus 4. So if we were to do that, so if we're going to find the integral of this function, in the last video we saw that since this is 6(1 to the first, we're going to add 1 to our exponent, so it becomes a 2, and then we also divide by that same number. So we're dividing by 2, or you could say I am multiplying by half. Same thing. But anyway, now we would do the same thing for our second term. Think of this as 4x to the 0. So this would become 4x to the first over 1. And so if we do that and go through our process that we did in the first video, this is the result that we would come up with. But now they're giving us a little more extra information so that we can get a constant for this function. So for this, if I now replace y with 10 and x with 1, I can solve for the c value. So this is the original function that we have right here. So it was y equals this. That's now the original function. And so now if I replace the x and the y with what I was given here, I can now solve for c, and I'm going to get that c is 11. Now I can now go ahead and take the 11, replace c with 11, and get this function right here. So same thing on this one. If you pause right now and give it a try, this would be a good time to do that. But again, I am starting with the derivative, and then we are going to find the integral of this function. And so if we follow that same power rule, we're looking at this is going to become x to the third over 3, x to the second over 2, x to the first over 1. So if we did all that and did a little cleanup, ultimately this is where we would end up with, and we have our plus c. But because they gave us this extra information, I can now replace my x with 2, set the whole thing equal to negative 17, just like you're seeing right here. And if we were to solve that equation for c, we find out that c is negative 15. So now we can throw in the negative 15 right there for c and get that function. Number 3, one more, just kind of the same. Again, this is the idea of putting things into friendly terms. So again, think of this as x to the negative 4th. And so this is the way that you would want to see it. Again, just be familiar with the proper notation here. We're going to do the integral of that function, and then we have our dx on the end, and that's going to ultimately get us to this stage right here. So doing the power rule, we're looking now at 1x to the first over 1. If I add 1 to negative 4, I get negative 3 divided by negative 3. And so if we did all that, this is the way it would look. If we want to put the negative exponent on bottom, this is the more appropriate way to leave our answer. But now we can solve for c with the given information that you see here. So if we plug those in, we get c is 8. And so we can now finish it off with that look. One more look here. Again, this is just another notation for derivative. You're kind of getting all the derivative notations here. So sometimes you get the prime notation, that means derivative. Sometimes you get the dy dx, that means derivative. And it looks like that was all we did in this one. So again, one more time, if you were to see this as 6x to the 1/2 power, now go through with that process. Just another different look at the notation here, but this is saying if I were to plug in a 4 for x, the result would be 7. So this is just another way of them telling you that when x is 4, y is 7. And so now we're going to be able to sub those in towards the end here and solve for c. And so if you go through that process, just follow along. Just like we did in the first few examples, this would be the ending look that we could come out with. And then last example for this, we are now looking for the equation of the curve. They're giving us another point here. We have a derivative. This is the exact same thing. just one more case. And so this is just another way of giving you an x, y coordinate so that you can get an answer for that c value. So if we go through with our antiderivative process here, so we're adding 1 to the exponent, we get 3x to the third divided by 3. This would be negative 4x to the second divided by 2. 3x to the first divided by 1. So that's what gives us this look right here with the plus c. Now if we sub in the negative 2 and the negative 18, we figure out that c is 4. And now we finish it off with this look here.